Hey guys, this is Mr. Lowry. I wanted to talk to you guys a little bit about parallelograms because this is part of your homework assignment. We're going to spend just a couple minutes kind of brainstorming some ideas about parallelograms, and then I'm going to give you kind of a little bit of a proof, or just a little bit of maybe evidence or reasoning behind why these things are true. Okay? This is actually on page 411 in your book, and it's the definition of parallelogram. So whenever we start with proofs and stuff, we always like to start by building on, definitions, postulates, or other theorems that we've already proven. So for parallelograms, this is where we're going to start. We're going to start with this idea. So the definition of a parallelogram is it's a quadrilateral, meaning it has four sides. So that also makes it a polygon, right? But the opposite sides are parallel. So opposite means they're not next to each other, right? These two guys would be like either adjacent sides or consecutive sides or something like that. Opposite are the ones that, they don't really touch each other, okay? And these guys are as well. So you see that shape, right? And you got those parallel sides. So I would probably add this to your notes. We didn't really get super far on this in class, but if you haven't already, I would add this to your notes. So I'm going to go ahead and draw it on a piece of paper here for you, and then we're going to brainstorm a little bit. So I got parallelogram. I'm going to do my best here to make it nice and parallel looking. I'm going to label the sides here, A, B, C, D. It doesn't really matter how we label it, but once we label it, we can use that to make some conjectures here. Okay, now here's what we know from the definition, right? The definition of a parallelogram is that the opposite sides are parallel. Okay, I'm going to just kind of use that abbreviation. Remember, this is the symbol for parallel. Okay, now you've probably studied this shape before, and so what I want you to do right now is brainstorm. If you haven't already, we did this in class in one of the periods, but in some of the other ones we didn't have a chance. What else do you know about the sides and angles of this shape? What do you remember? Or if you don't remember, maybe what do you think? So look at those angles there, look at those sides, come up with some conjectures, and then list them out, and we're going to see if we agree. So pause the video now and do that. Okay, coming back from pause, you should have kind of brainstormed a list of things that you think about these parallelograms here. And one of the things that you might notice or might remember is that it kind of looks like these two sides, these parallel sides, are not only parallel, but it looks like they're the same length. This almost looks like a rectangle that just kind of got smushed on its side. And in a rectangle, the opposite sides are congruent, right? So it kind of looks like a smushed rectangle. So a conjecture, or maybe if you might have known it from before or something, would be that the opposite sides are not only parallel, but congruent. So we have both. Let's mark them congruent now. We have the parallel markings already. Let's do congruent markings. Okay. Likewise, it looks kind of like this guy and this guy will be congruent to each other. A, B, and C, D. Okay? All right, let's talk about the angles for a second. Now, this guy is less than 90, right? It's like an acute angle. And this guy is greater than 90. It's an obtuse angle. And this guy is another obtuse, and this guy is another acute. So either if you know this before, maybe you looked at it and it kind of looks like it. Angle A is actually congruent to angle C. And angle B is congruent to angle D. And so what we're going to say, kind of for shorthand, is that the opposite angles are congruent. A and C are congruent, B and D are congruent. Okay. Now we haven't proved any of this stuff. We will in kind of just a second, and we're going to kind of do them all in one go. Okay. So opposite angles are congruent. Also, if you think about it for a second, we have parallel lines cut by a transversal. So imagine this is like the side of your parallelogram. And if you remember, these guys were called consecutive interior angles. And we knew from Euclid's fifth postulate that if these two lines were parallel, that these had to add up to 180 degrees. So A and B are supplementary. D and C are supplementary, right? But we also have parallel lines going the other way. So if you think about it, we got two parallel lines going this way with a transversal crossing kind of like this. So these guys are also going to be consecutive interior angles, which means they're also going to be supplementary since these are parallel. So what we're going to say is consecutive angles are supplementary. All right, so A plus B is 180, A plus D is 180, D plus C is 180, C plus B is 180. Right? Everything like that is going on for all the angles. Okay. All right. The last fact has to do with its diagonals. Now, we didn't draw any diagonals, so you may not have remembered this, or you may not have heard this before. But we've been talking about diagonals, and we know that a diagonal is a line in a polygon that connects two non-consecutive vertices. Okay, so this line is called a diagonal, and if you were to draw those two diagonals in here, you might wonder what's true about those. Well, it kind of looks like you have a short one and a long one, and it kind of looks like the long one gets cut in half, and the short one gets cut in half. Okay, so this little tiny section is congruent to this little tiny section, and this longer section is congruent to this longer section. Okay, a short way of writing that is diagonals bisect each other. They cut each other in half. Remember, bisect means cut each other into two congruent pieces. Okay, now these are things that if you don't already, you're going to need to know about parallelograms for your homework. Okay, so we want a short list. All of these are listed in this section, 8.2 on parallelograms. It starts on page 411, but we want to kind of have some ideas on how to prove these or some reasoning here. If you flip the page and you're in your textbook and you're on 412, you'll see all these properties, right? Properties of a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. There's this extra one about, having, if it has one right angle, it has four right angles, right? That kind of thing. And then over here, it talks about diagonals. Diagonals of a parallelogram bisect each other, right? Those are pretty much like the things that we talked about. The question is, how are we going to justify that? Because it says these are all like theorems. So they are properties which you can kind of use, but in this book, they're listed as a theorem, and that kind of requires proof. The good news is we actually did proofs very, very similar to this a little bit ago when we were talking about triangle congruence. So let me give you an idea, and this will actually help you with one of your homework problems. Let me give you an idea on how you can prove all these things are the case. Okay, starting with just parallel. Remember that we have a lot of information about parallel lines cut by a transversal. Okay, so if you have parallel lines and you cut it with a transversal, you get alternate interior angles congruent to each other. Okay, that's kind of a big key here. So if I take this guy and I cut here with a transversal, and I know these are parallel. Okay, these are my two parallel lines. This is my transversal. I'm going to get alternate interior angles congruent to each other. So that means this angle is congruent to this angle. Okay. The other thing that I know here is that this side is congruent to itself, which is cool. That's the reflexive property, right? And then also I have one other pair of parallel sides. So if you kind of think about it this way, you got your parallel lines, you got another pair of alternate interior angles, right? Alternate interior, alternate interior. And so what you have here is you have two triangles, and you have angle, side, angle for each one. So triangles congruent by ASA. That comes from the idea that the lines are parallel and then drawing the transversal. Okay, so these two triangles are congruent. Once you have them congruent, all other pieces congruent by CPCTC. Right? If I know these triangles are congruent, I've proved it by ASA, I get all the other pieces for free now, which means that this angle has to be congruent to this angle because corresponding parts of congruent triangles are congruent. CPCTC. And that means this side has to be congruent to this side for the same reason. And this side has to be congruent to this side for the same reason, right? As soon as I know the triangles are congruent by ASA, now I have all 6 pieces, side to side, side to side, side to itself, okay? Angle to angle, angle to angle, angle to angle. We have 6 pieces of congruent information, okay? So if you think about that, that goes back to this idea, right? Now in this shape, I was talking about 2 triangles, but now go back and think about it as a parallelogram. Opposite sides are always going to have to be congruent, because if you draw that diagonal, you're going to get 2 congruent triangles. So opposite sides are always congruent, right? Opposite angles are always congruent. Now, I could have done this the other way. I could have drawn the diagonal another way. And if I did that, then I would have this angle and this angle congruent. And so you have the opposite angles congruent. So I know that the opposite sides are parallel by the definition of parallelogram. Okay, as soon as I do this triangle thing, I know that opposite sides are congruent and opposite angles are congruent by CPCTC, basically. Okay, consecutive angles supplementary, that's Euclid's 5th postulate, right? We knew that these 2 angles are going to have to be supplementary if these 2 lines are parallel. And so we got parallel lines going this way, and we got 2 consecutive angles right there. Those have to be supplementary, and we have 2 parallel lines going this way, so those 2 guys have to be supplementary, and same with those guys. All right, so this just comes from Euclid's 5th. Check. Okay, let's talk about the angles bisecting each other now. Okay, so very, very similar idea. Let's draw some triangles. Okay, we're going to do the same kind of shape, parallelogram. Okay, so not a perfect parallelogram, but you get the idea. Okay, now we're going to draw both sets of diagonals. Okay, now the same kind of thing is going to be true. We have congruent triangles all over the place. These 2 guys are congruent. You can show that they're congruent a bunch of different ways, but it's basically kind of like taking these triangles and kind of cutting in half. But by using alternate interior angles and different things like that, you're going to get some congruent triangles in here. So it turns out that this triangle and this triangle are congruent to each other. And this triangle, sorry, let me shade them in for you. This guy and this guy are congruent to each other. The 2 dark ones and also the 2 white ones are congruent to each other. And so because these are congruent, their corresponding sides are congruent. So these must be the same. And then for the other, these guys must be the same. So this is, again, similar to another proof that we've done, and it kind of builds off this same idea, right? We've already proved that the opposite sides are congruent. Okay, and if the opposite sides are congruent, we got, all kinds of angles and stuff. We got alternate interior angles, we got vertical angles, we got sides. We can show that these are congruent. So because you have, either these 2 triangles or these 2 triangles are congruent, you get that this section is congruent to this section by CPCTC, and this section is congruent to this section by CPCTC. And if you think about it, these are the diagonals, and if this is the same length as this, and this is the same length as this, that means they cut each other in half. In other words, the diagonals bisect each other. So by building off this shape, this idea of congruent triangles, we just add another line in there. We still have, congruent triangles this way and this way. We use that CPCTC again, and we get corresponding sides congruent. We get the diagonals bisecting each other. Okay, so again, some ideas that you probably already knew, you probably have some familiarity with, but we want to kind of talk about those. We want to kind of review those ideas and then justify them. So not necessarily a formal proof. There is a proof that you're going to do on number 31, and this is basically the idea. All you got to do is write it out. So again, just really quick so you can kind of have some help with that proof. You start with drawing a diagonal, and you show that these two guys are congruent, you have the alternate interior angles. So these two guys and these two guys. Alt interior angles theorem. You have the reflexive property of congruence, saying that this side is congruent to itself. So the triangles are congruent by ASA, which means, you know, opposite sides are congruent, opposite angles are congruent by CP/CTC. So there's number 41 is going to ask you to prove this guy. Prove that opposite sides are congruent. What I would do is I would label a figure, something like this. Name the angles if you want to, put numbers in there. Prove that these two triangles are congruent, and then use CP/CTC. Okay? All right, I'm going to take a look at some of the homework problems with you and help you get started. Okay, so this assignment is on page 415. It starts on page, it starts on page 415, and it starts with problem 16. Okay, so here you're just going to answer some questions. Okay, now this is like almost the only time where you don't have to show any work, really. Because there's just not really a whole, well, it says justify your answer, so I guess what you can do is you can use the theorems here, right? So put which theorem you're using and how you know, but like DAB, for example, DAB, that's this guy, okay, that has to be congruent to BCD because these are opposite angles, so opposite angles have to be congruent. So this is just a matter of like identifying what opposite angles are, what opposite sides are, you know, parallel sides, and finishing those statements. So this should be not too hard. Okay, this guy is a little bit harder, and you're basically going to use some of the ideas that we talked about to set up and solve some equations. Okay, let me give you an example. We know that opposite sides are congruent, right? So that if this is a parallelogram, which it says it is, 3x minus 4 has to equal 20. So there's an equation right there. You can set up and you can solve for x. Right? We also know that 2y plus 5 has to equal 17.9. So that's another equation. Okay? You have some angles in here that are, you know, a little bit hard to see, and you have some sides that are a little bit hard to see as well. So this 15.4 is this guy right here. Okay, this 11.1 is this guy right here. Okay, I know that's kind of hard to see. This 3z minus 3 is this one right here. And then this 4w minus 3 is this guy right here. Okay, I know that's kind of tricky. 33 degrees is this little tiny angle, not the full angle, just this little guy right here. This guy's 38, right? But remember, we got alternate interior angles. So if this is 33, then this better be 33. And if this is 38, then this guy better be 38. Okay. Also remember that the consecutive angles, this full angle and this full angle, have to be supplementary. Okay. And then also the opposite angles have to be congruent. Right. So might be a good idea to draw that out and make things a little bit bigger to kind of help you with that. So let's do that really quick together. I think that will maybe help you get going. So I'm going to draw this a little bit bigger and help you with the labeling. All right, so something like this. We got M, N, R, P. Okay, here's a diagonal, here's a diagonal. So the top is 3x minus 4. Right? And the bottom is 20. So one of our equations is 3x equals minus 4 equals 20. That was going to help us find one of the things that we need. Okay. We also have this guy at 17.9. That's this side, and we have this guy at 2y plus 5. Right. So another equation that we can set up here is 17.9 equals 2y plus 5. Okay, now we got this angle is 33 degrees, so that's not the full angle, that's just this part of it. And we got this guy is 38 degrees right here. Okay, and again, remember that alternate interior angles have to be equal, so this guy has to be equal to this guy, and this guy has to be equal to this guy. Okay, so that's kind of another hint there. So 38, 33, 33, 38. Okay, now the diagonals is where it gets kind of hard to see. So where it says 15.4, that's this guy. Okay, this guy is the diagonal. Notice it doesn't have a degree symbol. It's talking about the diagonal. And this diagonal is 3z minus 3. Okay, so you have those two. And then the other diagonals, this guy, kind of hard to see, but 4w minus 3. And this guy is a 11.1. And then this one is 83 degrees. So the 83 degrees is this. Okay, some other ideas that might be, something to think about is the triangle sum theorem. So you kind of, if you have this angle and this angle, then you can figure out what this angle is too, because they all have to add up to 180. So 38 and 83 and this angle have to add up to 180. You also got vertical angles, which makes this 83. You got linear pairs all over the place. So if you want to find like these angles, you can use the triangle sum theorem. You can use vertical angles here. You have all kinds of stuff going on, but you also have these facts about parallelograms that we've been talking about. Okay, so that's not the whole problem, but that's just kind of getting you the labels. I think the labeling is probably the hardest part, helping you set up a couple equations. You're going to go through and you're going to figure out the rest of the pieces based on not only the new stuff about parallelograms, but also stuff about, like I said, vertical angles, triangle sum theorem, alternate interior angles, all the other stuff that you know. Those are going to be helpful ideas. Okay, now the last one here is write a proof, right? So let's see if I can get this in here without accidentally unplugging the camera. Okay, 41, two-column proof of theorem 8.3. Okay, well, theorem 8.3 is that opposite sides of a parallelogram are congruent. So I would start again with a picture. You can label it however you want. Let's do A, B, C, D. Let's draw a diagonal in there. And let's label these parallel and these parallel. Because that's what we have to start with. We have to start with the definition of parallel. Okay? Haven't proved anything else yet. So statements, reasons. Okay, statement 1 is going to be that AB is parallel to DC, and that BC is parallel to DA, and that's going to be definition of parallelogram. Now it's kind of given right from the picture, but so you could probably say given because we're talking about a parallelogram, or given this is a parallelogram. Okay, step 2. Okay, now we're probably going to use some angles here, so let's do this. Let's label this guy 1 and 2 and 3 and 4. Okay, so angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. And remember, we know that because alternate interior angles, right? We have these parallel lines cut with a transversal, and so we have some alternate interior angles going on here. We actually have 2 for the parallel lines going this way, and then 2 for the parallel lines going this way. Okay, so alt int angles theorem. Okay, remember that this guy is congruent to itself, right? So 3 AC congruent to CA. This is the reflexive prop. Equality. All right, now I'm going to let you finish the proof. We kind of already talked about this. I kind of already talked about it when we talked about the notes here. All right, there's important ideas here in this guy. Okay, you can show that these triangles are congruent now. You have all the things that you need to show that they're congruent. So think about what you have here. Once you show the two triangles are congruent, you have all the other sides congruent and all the other angles congruent. Okay, think about why that's the case and how that's the case, and that should kind of help you there. All right, so that's not a whole lot of problems, but that should give you the idea, that should give you the setup, that should kind of help get your brains going, and then you can kind of think through the rest of it. All right, thanks guys.